Our topic is trigonometry now. Trigonometry is basically relation between sides and angles of a right angle triangle. Okay, so as we are going to discuss angles here, now we will first understand angle. So angle name is given to rotation between two rays. So if any two rays are there and they are at some rotation with each other, means if we consider this is the first ray here, this is the second ray here, second one is rotated somewhere with the first one. So if you want to measure the rotation between both the rays here, that is named angle, and we will use a symbol here, theta. Okay, this symbol that we are using here, that is theta. Okay, so theta, as we have defined here, this is carrying unit also. So unit of angle we will write here, that is degree, that you have seen in the previous classes, and the new degree that we will, new unit that we will use here is radian. Okay, and radian is going to be your SI unit here, the standard unit that we will use in physics. Okay, so if you are going to give any answer in the physics, you should try to give it in the radian form only. Okay, now we know degrees very well. So consider if a complete circle is there, this is one complete circle, we know this have how much angle covered here, we will say 360 degree is completed here, right? Now first we need to understand how to calculate radian. So angle in radian will be equal to the arc length divided by radius. Understand with an example. Consider these are two rays here and we want to find the angle between them here. Consider that is theta. So if this is the case here, angle between the two rays here theta. Now as we can see here, these two are subscribing a circle here, right? If we are subscribing a circle here, then we should have a radius also here. Consider that radius is r here in this case. Okay, now this subscribed circle here, part of a circle here, it have some length here, we are naming it as arc length. Okay, so arc length we can find using thread or something if you want to calculate this angle. So practically we can find this arc length and we will have the radius also. So if you want to find the theta in radian, what you need, arc length divided by radius, that will give you the angle in radian. Okay, so for complete circle, if we'll try to find angle in radian also, what we will do, so theta in radian will be equals to arc length. So if a complete circle is there, its arc length will be how much from here to here? Arc length we know it is going to be 2 pi r and divided by its radius, so radius is going to be r only, so these r will get cancelled, and theta in radian for a complete circle, is equals to 2 pi. Okay, so we can compare these two. Okay, how we are going to compare? Theta for a complete circle will be equals to 360 in degrees and 2 pi in radian. So we have this conversion factor also here. If we want to find 1 radian, what we will do? We will take 2 pi to the other side, so that will become 360 by 2 pi. Here 2 we can cancel, so this is going to give us 180. So in 1 radian, how many degrees are there? So that is 180 by pi degrees. Okay, this you can remember. Other relation, if you want to find how many radians are there in 1 degree, so what you will do? So from here we can find 1 degree is equals to 360, or this 360 we are taking to this side, no? So 2 pi already it is there, divided by 360. This is in radian now. So how much this will become? In 1 degree, pi by 180 radians will be there. Okay. So now it's your choice which one you want to remember, this one, or this relation. Just you should know the conversion from degree to the radians, because now we will be focusing more on the radians, and until now we are comfortable with the degree system. Okay, so we should know this conversion here. I'll suggest you remember pi radian is equals to 180 degree. Okay, from this I just cancel 2 here, so this you can remember. Okay, now we can take a question here. If I say convert theta into radians. Okay, I am giving theta in degrees and you have to convert that in radian. Okay, for 0 degree, 30 degree, 45, 60, 90, 120, 50, 180, 270 and 360. Okay, so try this. Convert the angles into radians here. Okay, so when you will convert 0 degree, it will remain 0 radians only. Okay, if there is no rotation, that will be 0 in degrees, that will be 0 in radians also. Now if you want to find 30 degree here, we know that 1 degree is equals to pi by 180 radian it is. We want to find 30 degrees, so what we will do, we will 30 multiply here and multiply 30 here also. Okay, so here it will get cancelled with this one, and 3 cancels 18 and it will give 6. So 30 degrees what we will get, pi by 6 radian. Okay, same way you have to convert all the angles given here. Okay, so this is pi by 6. 45 degree if you want to convert, we will do the same thing. 1 degree is here, that will be equals to pi by 180. We want to find for 45 degrees, so we will multiply 45 on the both the sides. Okay, so when we are cancelling this out, we will get pi by 4 here. Okay, so 45 degrees is how much? Pi by 4 radian. Same way you can find out all the angles here, so I'll just write it here. 60 degrees pi by 3, 90 degrees pi by 2, 120 degree will be 2 pi by 3. Okay, and 150 degree is 5 pi by 6. 180 degree we know from the relation that we have to remember, it will be pi only. This will be how much? 3 pi by 2, and this will be your 2 pi. So these are few general angles whose conversion you should remember, because this is you will not do in the exam. Okay, these are few general angles here. We have trigonometric ratios. So as we know how to find the angles, how we will use it? Consider one right angle triangle is here. This is one right angle triangle and we have to assume some angle here. So consider this angle we are assuming as theta here. Okay, if this angle is going to be theta, this is right angle triangle, so this angle will be 90 only, and sum of all the angles in a right angle triangle is 180 degrees. So consider this is alpha. Okay, so sum of all angle means 90 plus alpha plus theta is equals to 180, right? 90 I'll take there, so it will subtract. So alpha plus theta will be how much? 90. So theta will become how much, or alpha value if we want to find. So alpha will be your 90 minus theta. Means this angle here is going to be how much? 90 minus theta. Okay, so if one angle is theta here, other angle will be 90 minus theta. So we will do the calculation based on taking theta angle here. So we are going to name the sides also here, because in trigonometry we are going to find the relation between side and the angle. So opposite side of theta means this side is the opposite one. So this is called here perpendicular. Okay, adjacent to it means just beside it, that will be your base, and longest side we know, if the longest side is here, that is called hypotenuse. Okay, I am using abbreviations here, P, B for this one, and H for the hypotenuse. Okay, now we have some trigonometric ratios. First is your sine ratio. Okay, so sine of theta will give you what? That will give you the ratio of perpendicular with the hypotenuse. Then next is your cosine ratio, that will give you ratio of base with the hypotenuse. Okay, after that we have tangent. Tangent, right? So tangent tan theta will be equals to ratio of perpendicular with the base. Okay, after that cosec theta we will find here. Okay, so cosec theta will be equals to just inverse of sine here. We can write it as 1 by sine theta, and that will be equals to hypotenuse by perpendicular also. Same way here, inverse of cos theta is called secant theta, that is sec theta. So that will be equals to 1 by cos theta, and you can write it as hypotenuse by base also. Okay, same thing here with the tan also we will do. So that will give you cotangent, we say it as cot theta. Okay, so cot theta is basically 1 by tan theta, and that we can write as base by perpendicular, just inverse of the tangent. Okay, so these trigonometric ratios you should remember here. After that there are few general angles for which you have to remember the value of these ratios. Okay, so I'll give you the table here. This is sine, this is cos, and here it is tangent. For which angles you have to remember it? 0 degree, 30 degree, 37, 45, 53, 60, 90, 180. Okay. These two are new for few people. So you have to remember this because mostly we will use this in physics. Okay. So sine 0 is going to be 0 only. This will be 1 by 2. I'll just write the values here. You have to remember them. Okay. Now 1090 is a catch for us. That is going to be 1 by 0. Okay. And in physics what we do, we will not write as undefined, we will write it as infinity. We will write it as infinity here. Okay. And 10 180 will be 0 only. So whenever you see 1 by 0 in physics, you can write it as infinity. If you are getting 1 by infinity, you can write it as 0. And in any question, if you are getting 0 by 0 or infinity by infinity, then definitely you are doing the question wrong. You should not get this. Okay. These two, if you are getting, you can convert it this way. Okay. And this table must, you have to remember it. After that, there are few identities that you have to remember for the trigonometry. Okay, so what are those identities? First, that is sine square theta plus cos square theta, that will be equals to 1. Second is 1 plus tan square theta is equals to secant square theta. Okay. Third is 1 plus cot square theta will be equals to cosecant square theta. Okay. So these three identities you must remember. After that, we have few more identities that is mostly new for few people. So first is here sine A plus B. Okay, sine angle is addition of two angles. So in that case, what will be the expansion of this? So this will be sine A cos B plus sine B cos A. Okay, so this will be the expansion here. Next identity, sine, if A minus B is there, in that case what will be the expansion? So that will be sine A cos B minus sine B cos A. Okay. Next identity, cos of A plus B. This you have to remember. So this is going to become cos A cos b minus sin a sin b. Okay, next identity, cos a minus b. If this is the expansion you have to do, it is going to be cos a cos b. Here it will be plus symbol now, sin a sin b sin b. Okay, so these new identities you must remember, it is useful. Okay, and other three, these are definitely useful because these are from the previous classes also. Okay, now if I'll give a question here, where to use, how to use this identity. First question, so consider I am asking you here sine of 82 degrees. Okay, so how will you find the value of sine of 82 degrees? Because we only remember the value of 0, 30, 37, 45, 53, 60 and 90. These values only we remember, right? And in that 82 was not there. So here what we need to do, we have to check this 82. Here it is sum of or difference of which angles here. It is sum or difference of which angles here that are known to us. Okay. So here consider 45 degree angle, we know its value, and 37 degree we know its value also. If you try to add these two angles here, what we will get? 45 and 37. This will give you 12 and this will become 82 degrees. Means if you are adding 45 and 37 here, that will give you 82. And values of 45 degree and 37 degree we have. So we can write this sine 82 degree as sine 45 plus 37 degrees. Okay, so you cannot write here sine 45 plus sine 37. Okay, so that will be wrong here, because here angles are getting added, not the different values are there. So you cannot write this. What you have to do here, you have to expand it here using the identities that we have written. Okay, so sine is there and two angles are getting added. Which identity we will use? We will use sine a plus b. So that will give you sine a cos b plus sine b cos a. Okay, so I'll write here sine of first angle, that is 45 degree, multiply with cos of next angle, that is 37 degrees, plus sine of the second angle, that is 37, cos of 45 degrees. Okay, so this is how it will become. Now we have to just write the values. Sine 45 is how much? 1 by root 2 from the table. Cos 37 is 4 by 5 plus sine 37 is 3 by 5 multiply with cos 45, that is 1 by root 2. Okay, so this finally here we can take common what? 1 by root 2 and 1 by 5. So we have remaining 4 plus 3 here. So finally this will become 7 by 5 root 2. So this is going to be the value of sine of 82 degrees. Okay, this is how you have to find the values of the angles which are unknown to you. So these questions, try it out. Okay, after that we will continue the identities we were writing. Now next identity, eighth identity, will be our tan of a plus b. If tan a plus b is there, then it will become tan A plus tan B divided by 1 minus tan A tan B, right? Next we will take a case here. If A is equals to B is equals to some theta angle, if both the angle that we are adding here are same, so in that case what will happen? So in that case, consider, for example, I'll take sine of 106 you want to find. Okay, 106 is made with the addition of 53 plus 53. Okay, so two angles are here which are getting added, but both are carrying the same values here. So in that case, how the identity will become, that we are finding here. So first we will find the general solution here, then we will take the example. So sine of A plus B will become what? That will become sine theta plus theta. We can write it as 2 theta. This will be theta. This will be also theta. Theta get added and gives you sine 2 theta. So that will be equals to sine A cos B plus cos A sine B. So as here all the angles are same, all the angles are theta, we will write it as theta only. Okay, so what is finally we have sine theta cos theta plus cos theta sine theta. Okay, and both the terms here as we can see are same. This is same with this one, so both will get added here. So that will finally gives you 2 sine theta cos theta. Okay, so we can remember this general solution. Sine 2 theta is equals to 2 sine theta cos theta. Okay, and this is also important, so you have to remember it. Same thing we can do for cos also. Cos of A plus B will become cos 2 theta, and that identity was cos A cos B minus sin A sin B. So this will become cos theta into cos theta, that will give you cos square theta minus sin theta into sin theta sin square theta. Okay, so this also you have to remember. Cos 2 theta is equals to cos square theta minus sin square theta. This is important, right? Now as we have this identity sin square theta plus cos square theta, that is equals to 1. Okay, now we can use it here also. Consider first case, sin square theta I want to remove from here. I want my answer in the form of cos square theta only. So what I will do, I'll use this identity, that is sin square theta is equals to 1 minus cos square theta. So on the place of sin square theta I'll put 1 minus cos square theta. Okay, so this is going to become cos square theta minus 1 minus cos square theta. So here what we will get, cos square theta already it is here, plus minus 1 plus cos square theta. So these two will get added, that will give us 2 cos square theta minus 1. So we can remember this also here, cos 2 theta is equals to 2 cos square theta minus 1. Same thing we can do for the elimination of cos square theta here, if we want our answer in the form of sin square theta only. So I am going to do here cos square theta substitution, we can write it as 1 minus sin square theta. We will put that in the equation here. So it is going to become 1 minus sin square theta minus sine square theta. It is 1 minus 2 sine square theta. This is a cos 2 theta. Okay. So for cos 2 theta, you have to remember these three identities here. Okay. And all are going to be important in different question. You will use different identities. So these three you have to remember. Now we will go back to our example. Sine of 106 degrees. Now it is addition of 253 angles. So I'll write it as sine 2 into 53. Okay, so here theta is our 53. We can use sine 2 theta identity here. So sine 2 theta is equals to 2 sine theta cos theta. Now we can put the values here. 2 into theta is our 53 degree. So sine 53 into cos 53. We will just substitute the values now. Sine 53 is 4 by 5. Cos 53 is 3 by 5. Finally, this will become 12 into 2, 24 by 25. Okay. So this you need to remember. After this, try one question by yourself. Question is, find cos 106 degrees and cos 74 degrees. Find sine 74 degrees also. Okay, so this part you have to complete. Write the 10th identity, that is sine of minus theta. Sine of minus theta, we can write it as minus sine theta. Okay, how you will do that? Understand from an example. Sine minus 37 degrees, if they are asking you value of sine minus 37, so you can write it as equals to minus of sine 37, and we know the value of sine 37, that is going to be minus, already it is, sine 37 will be 3 by 5. Okay, so this is how you will use it. One more identity, cos minus theta, that you can write it as cos of theta. Okay, same thing here. Last thing that you have to remember is quadrants. We have graphs also, but that will be taken for all the function in a topic, different topic. Okay, so graph we will discuss there. Okay, now quadrants that you have to remember. So when the ray is not at all rotated, that will be making 0 degree angle here. When it will be perpendicular, it will be making 90 degree angle here. When it is on the another side, 180 degree, this will be 270, and when it will complete the rotation here, we know it is going to be 360 degrees. Okay, just opposite. When it is completing one circle here, 0 degree can be written as 360 degrees also. Okay, now from 0 to 90 degree, when your angle lies between 0 to 90 degree. Okay, so in that case we call theta 0 to 90, we call it as acute angle. Acute angle. And whenever is your theta is between 0 to 90 degree, we say that is first quadrant. That is first quadrant, right? Next will be next will be 90 to 180 degree. In that case, theta will be called obtuse angle. And this is called your second quadrant, right? After that, 180 to 270 degrees, we named it third quadrant. And for 270 to 360 degrees, that is named fourth quadrant, right? Now, one thing that you have to remember is a cast rule. CAST, cast rule here. Okay, how to use it? C you have to write in the fourth quadrant, then A in the first quadrant, S in the third quadrant, T in the S in the second quadrant, and T in the third quadrant. Okay, now here C means cos, okay, A means all, and S means sine, and T means tan. So whenever is your angle between 0 to 90 degrees, all ratios will be positive. Okay, all ratios will be positive, means they will give you the positive values here. Now, if your angle is from 90 to 180 degrees, in that case, sine will give you the positive value. Sine will give you the positive value. Here, cos will give you negative, tan will give you negative. Okay. Now, third quadrant, if you're coming here, in that only tan will give you positive, sine and cos will give you negative here. In the fourth quadrant, we can guess now. Cos will give you positive value, others sine and tan will give you negative value. Okay, so this is how you have to remember. C in the fourth quadrant, A, S, T this way. C will give you means cos positive is in the fourth quadrant. All are positive in the first quadrant. In the second quadrant, sine is positive. In the third quadrant, tan is only positive. Right? So this is our quadrant rule. And one more thing that we are able to observe here, that we started from 0 degree angle. After completing one circle, we came back to the 360 degree angle here. Right? Now means after completing one circle, we are coming back to the same value here. Means 0 and 360 degree are not different. They both will give you the same value. If sine 0 is there, that we can write as equals to sine 360 also. Same way, initially if some angle is there, consider that is theta. Okay, and you started moving from here. You completed one circle, so that is 360 degree. Further, you came back to the same point. So total you have traveled 360 plus theta here. You reach to the same location here where theta rotation was there. So now we can write as sine of theta is equals to sine of 360 plus theta, right? If you complete one more circle here, that will be plus 360 more, right? So we can generalize this now here. We can write sine n into 360 plus theta is equals to sine theta. Okay, and n can be anything. It can be any integer, but it should be integer. 1, 2, 3, so on, right? How I am saying this? When we completed one circle, it was 360, one only. When we completed two circles, so 2 into 360 was there, so n will become 2. When it is more, it will be that integer only, right? In the terms of pi radian also we can write it. So sine n into 360 in radians is 2 pi plus theta, that will be equals to sine theta. Here you can remember sine 2n pi plus theta is equals to sine theta, right? So this is important, you should remember this. Same thing is valid for cos also. So cos 2n pi plus theta is equals to cos theta. Okay, we will again see these things in the graphs also.